and we decided that the start frame of our explosion was going to be frame 81. So let's drop in a pyro solver, set the start frame to 81. And for the resolution of this pyro solver, I'm going to start by setting it to what we've already set on our density source here, which is 0.15 on that voxel size. We can of course tweak this for more or less resolution if necessary, and let's connect our source to that. And right now, our source is only changing from frame 81 up through 87. At frame 87, it's just going to hold this ring at the edge of the shockwave here, and we don't want it to continuously source from this little ring source there. So oftentimes, to prevent the network from cooking and prevent us from adding more sourcing when we don't need it anymore, I will drop in a switch just before the pyro solver. And then on this select input, I'll say at frame is greater than 87, drop in a null and connect it to that switch as well. So if you display that, you can see that once we get above frame 87 here, it's going to just switch over to adding nothing extra to the sim. And now to add collisions, we can wire those into the second input of our pyro solver, and this can create your collision just from passing in geometry, or you can tell it that you're passing in a collision SDF with volume velocity, and this gives you a bit more control over exactly how those collision volumes are constructed. So if you want to be lazy, you can just try passing in some collision geometry, but generally I like to build my colliders so I know exactly what they're doing. So on our trimmed environment here, let's display that. And right now this is just a planar surface geometry. So to create a nice collision volume for this, let's give this some thickness. So I'll drop in an extrude volume, connect that to our environment trim, and it looks like the default settings of our extrude volume should work just fine. And now let's drop in a collision source on this. And the first output of the collision source is going to be geometry, and the second output is going to be a collision volume. So it's that second output with the volume that we want. So let's go over to the volume settings here. And for the voxel size, I often like to reference this to the actual pyro solver settings. So on the pyro solver, let's copy the voxel size here. So copy that parameter, and we can actually use that for our density input volumes as well. So on this volume rasterize attributes, I'll paste in a relative reference there so that this matches any changes we make to our pyro solver resolution. And then on our collision settings over here, we can actually often get away with less resolution on our collider than we have in our actual simulation. So let's paste in the relative reference there so that this will match the pyro solver resolution. But if you want to make this a little bit faster to generate, you could potentially add a multiplier to that resolution here. So I think it's fine if we just want to double the voxel size for our collider. And let's drop in that null, connect it to the second output of our collision source and display that. And you can see that even with this set to double the voxel size of the pyro solver, we're still getting quite a lot of detail in this collider here. And this is still the low-res version of the environment, so if you want, you can certainly change our object merge here that's bringing in the environment and swap in the high-res geometry instead, but I'm just going to try leaving this on the low-res geometry because I think it'll be close enough for the purposes of our shockwave. So now our collider is all set up. We don't currently have any collision velocity, but that doesn't really matter because this is just a static terrain. So let's connect this collider to our pyro solver's second input, and then go back to the start frame of our simulation, display that pyro solver, and template display our reference geometry, turn on the viewport lighting once again, and then let's see what this shockwave sim looks like now. So checking out the results of the first simulation, this is looking like a promising start. However, everything is being blown apart too quickly by the velocity, and it's all dissipating very quickly as well, and we definitely need to tone this down quite a bit in a few different ways. It's also looking very, very thick and dense here, and I want the shockwave to look a bit lighter and not just this heavy, heavy, thick cloud like this. I mean, perhaps a heavy, thick shockwave cloud can look cool, but for this shot, that's not quite what I was looking for. So on the Look tab, we can lower the density scale here. Let's go to a sim frame where we can see that a bit better. So on frame 83, you can see that's looking quite dense. Lowering that density scale to about 40% is looking quite a bit nicer. And another thing I like to do is ramp down the amount of density that's being added after the start frame. So right now we're adding 100% of the density in the input on every frame. So I like to use an expression in here. So I'll do a fit function based on the current frame. So I'll start this ramp down at frame 82 so that we get a couple frames of full density emission, and then have it completely turned off by frame 88 and ramp that density scale from 1 down to 0. We can remove this burn and flame source here. That's not necessary for a shockwave. And the temperature here is going to affect buoyancy, and in order for buoyancy to work properly, we need to add some temperature in here. Currently, we're not sourcing any temperature, and sometimes I will actually use the density as the source volume here and add that into the temperature field. But since I actually like this initial behavior, I'm going to leave this alone at the moment. And I'll only start playing around with this if we really need to adjust the buoyancy of the sim. And then for the velocity sourcing, we're actually getting much more velocity influence than we really need here. And you can kind of see a lot of these very spherical shapes appearing like this. And this is one of the classic problems with volumetric sims. And you'll be fighting these kind of like spherical mushroom shapes quite a bit when you're doing simulations that have a lot of high velocity input. And there are a few ways that you can address that. One of the easiest ways is to simply reduce the amount of velocity that you're adding in here. And I already felt like this simulation was completely blowing away all of this dust far too quickly. I want this shockwave dust to kind of linger around on the terrain here and just get a bit of a push away from that explosion. So I'm going to try setting that scale to 0.1, so we only get 10% of the velocity added to the sim. And if we go to the Export tab, this probably won't make much difference, but on the output from our Pyro solver, all we really care about is density and velocity. So we can remove the temperature and flame and color exports if you want. Under the Solving tab, this is where some of the most important settings live. Under the Shape tab here, we can set our dissipation and turbulence and disturbance. For a dusty, smoky sim like this, we generally don't really need to deal with shredding at all. And we're going to talk about shredding a bit more once we get into the fire simulation, but it's not really necessary for our shockwave here. We are going to need to turn down the dissipation because I really want this shockwave dust to kind of linger in the air for a while after the initial emission. So I'll turn that down quite low to 0.01. Let's turn on the disturbance and crank that up quite a bit. And then go to the disturbance tab here, and it's very important to set a reasonable block size for this. And we have two different options for our disturbance here. And the continuous option doesn't actually use the block size. This will generate a random vector per voxel to break up that velocity field at the smallest representable level given our voxel resolution. Whereas the block-based disturbance will add a noise of explicit sizes to break up the velocity field. So it's up to you if you want to play around with that, or just do explicit block-based disturbance here. And to help determine the base block size for this disturbance detail, sometimes I like to add in a reference box. And for the box position, maybe I'll grab that from the circle's position here. I'll copy that center position parameter, and on the box, I'll paste that in there as well. Paste the relative reference and that center parameter, and let's display that box. And if we zoom in here, this box with a size of 1 can give you a rough idea of the size of the disturbance detail that's going to be added with a block size of 1. So this could work reasonably well to add some larger scale disturbance like this, but I generally like to go a little bit finer with my disturbance than that. So I'm going to try probably half that size. Let's try a scale of 0.5. And this disturbance is essentially going to break up the velocity for some more detail. And a velocity breakup detail size of 0.5 like this seems like a good starting point. So back on the Pyro solver, I'll set the base block size to 5. And I'm not going to go over every single parameter here and describe what each one of those does when you can easily check the docs for some more information on these. But a couple key ones to point out are the max octaves here. So in block-based disturbance mode here, it's not only going to add in a disturbance size that we've set here of 0.5, it'll add up to a couple layers more of smaller disturbance as specified with the max octaves here. And the roughness determines how much amplitude each successive layer of disturbance has. And this lacunarity determines the relationships of the size of the block size with each successive layer. But I think all of these defaults are going to be fine as they are here, at least for the next version of our sim. So now let's also enable the turbulence. Crank up the turbulence amount a bit as well. And on the turbulence tab, similar to the disturbance, we need to set a size for this. And often with simulations like this, I like to use the disturbance for the really fine detail, but the turbulence for the larger scale swirls. So I'm going to try a swirl size of 2, and I'll leave everything else at default for now. So as for our shape settings, I think this all looks good to run a new simulation. Just to take a look at a couple other things in here. We don't need to worry about the flame settings for our shockwave. Don't really need to deal with the color either. Under the Advanced tab, I'm going to leave all this stuff alone. However, sometimes for fast-moving simulations like this, you may need to increase the padding on your resize, or you might be hitting the bounds of the simulation because it's expanding too fast for the resize to account for it. And this shockwave does move and expand pretty quick, so it's very possible you may need to increase this padding here. Over on the Simulation tab, you can speed up or slow down the overall behavior of the sim with your time scale. For something like a shockwave, we probably don't need to mess around with viscosity or anything else. These buoyancy settings can be quite important, but at this point I'm kind of happy with how the simulation is behaving in terms of buoyancy, so I'll leave that stuff alone for now. And let's rewind our sim and see how this looks with the updates applied. And now reviewing our updated simulation, this is looking pretty good. And of course, it would be much easier to dial this in to get the behavior just right if we had the explosion in there as reference. As I said earlier, typically you wouldn't be doing the shockwave before you do the explosion, but since we're learning here, I wanted to teach you these density volumetric simulations first before we get into all of that combustion type stuff. And yeah, this is all looking pretty good. I'm pretty happy with this. There are some issues with perhaps this area on the far side of our simulation here. This is getting a bit sparse and we're seeing a couple bands of density here. So you might want to perhaps, thicken up the source a little bit in this region here. And you can certainly, finesse certain parts of your simulation source like that. but I'm not going to worry about it too much. That will probably be covered up by the explosion anyway right there. And it's also a good idea to start rendering your results before you really fine-tune a lot of these little details, because with volumetric effects in particular, they're really dependent on how they're rendered. And in the viewport we are seeing some little voxel grid artifacts and such. Some of this stuff might not be so apparent in the render. And you can add in additional microsolvers on top of your standard shape settings on the PyroSolver here. Under the Solving tab and Shape, we have our standard disturbance and turbulence here. But if you have something you like and you don't really want to change this, you can dive into the PyroSolver here and then start adding in additional microsolvers. Like, for example, if you wanted to add another gas disturbance, and then maybe a gas blur, and a gas diffuse. And we can merge all of these microsolvers together. Just drop in a merge, connect all of those, add that to our force output. And this allows you to just really build up some extra additional fine-tuned controls with all of the DOPS microsolvers that are available to you here. For this, I really don't think we need it, because our sim is looking pretty good, and I'm not really seeing any problematic voxelization artifacts, and I think this is in good shape to start rendering it. So let's jump out of our PyroSolver here, add in a file cache, connect that up to our PyroSolver. I'll set the start and end to go from frame 80 to 240, create a new Shockwave sim directory, call it shocksim.$f3.bgo.sc, accept that, turn on load from disk, and then hit save to disk to save out this entire frame range. And now after simulating the entire frame range and flipbooking the results, we have a shot that looks like this. And this is looking quite cool. Of course, we may want to really get in there and finesse things once we see the explosion in there with it, because we may want to adjust things in context. But overall, this is looking quite good, and I'm happy with this, so we can go ahead and start rendering that.